now, there has been a lot of talk recently about what's been going on in a galaxy far, far away. No, it's not about Star Wars, but a rare discovery by a group of international scientists who have seen how planets come into existence.
They're observing and photographing a baby planet in the early stages of formation and say it will help us understand more about our solar system. One of the scientists involved is an Australian professor who joined Dr Karl to tell us more about the discovery.
Well, this man here is part of a team. Let me introduce to the microphone and the camera. Hi, everybody. Professor Peter Tuthill. And there's this sort of process where you start off with a big bang and a lot of stuff happens and then here we are. And there's steps in between.
Yeah, that was a brief summary of a lot there, Carl.
And one of the steps is that you get galaxies and stars, but how do you get stars and how do you get planets? And to give the bottom line, Peter was the guy who is part of the team that is actually seeing the first planet that we've ever seen form into existence. So you've got a galaxy which is like a Milky Way, a couple of 100,000 light years across and, you know, fairly thick in the middle, and we're about halfway out the edges. And in between the stars, you only got about 100 particles per cubic metre, but there's about 6,000 clouds in there. Molecular clouds, we've got 100 million particles per cubic metre, which is still very thin, the finest vacuum we can make. And from this forms stars and then planets.
Tell us a little bit about this discovery.
So it's the first really concrete case where we've joined all of the dots between a star being formed and the sort of in-joke in astronomy runs that star formation, planetary formation is the round-off error to star formation. It's just these little tiny flakes of dust that are left over. So most of the mass when a star's formed goes into the star itself. But left over, there's this dusty disk that's orbiting around the star.
Like a 0.5% or a 0.1%, something microscopic, you know, rounding off error.
Yeah,
that's us, that's you and me.
It's a tiny, tiny fraction of what goes into the star, but it's still a vast amount of mass because it's enough to make all of the planets and then with lots left over. So what we've seen here is the first case where we've been able to really join all the dots. So we've seen this disk, and we've seen that there's a gap in the disk. So something's eating away at the material that's circling around the star. What could that be? Well, unfortunately, there could be a lot of things that could be. There's a number of reasons you could have a gap in that disk. And it's exciting to think, well, there's a gap there must be a planet eating it away. But there are several other explanations, so it's not enough just to see the gap. But what we've seen is inside the gap, we've seen a couple of little tiny planets orbiting around. We've seen them in orbit, so we know they're planets.
So you actually got little pixel, a pixel or two, saying that's a planet. The telescopes are that good now.
Yeah, they're that good.
Wow.
Well, not only that, Carl, we've seen them move, so that we went and looked at them one year, and then we came back a couple of years later, and they'd moved in their orbits, just the same way the orbits in our own solar system.
Okay, so you've got a big cloud of gas and dust, and it condenses somehow to form... What do you have, a density perturbation go through or something, and that forms a star, and so you end up going from a big 3D thing to a star and then a flat disk, and then in this flat disk you've seen gaps.
Inside the gap there are two, and maybe three, but certainly two little clumps, and those little clumps look like they're in orbit. But the real, I guess the real icing on the cake is that one of those two clumps we've seen this little faint gleam of red light. And that gleam of red light comes from hydrogen. It's just like a neon tube, except that the gas in this case is hydrogen, excited hydrogen. And we can see the shocked hydrogen that's a result of this column of gas falling down and actually forming the new planet. So we're actually watching the process of planetary formation in process.
So this really turns science on its head.
Well, it's a really nice demonstration of something we expected had to happen. We've never seen it before, and there are a bunch of things that do turn the theory on its head about this discovery. It's a very large planet for the time. Planet formation is a little bit of a race against time. The star's formed, and that forms quite quickly, and then we've got this remnant disk still in orbit around the star, but the star doesn't take very long before it dispels that.
Oh, because it gets so hot it blows it away by the pressure.
It blows it away, it's its own radiation. So there's a race. So planetary formation, the theory of planetary formation is quite problematic because you've got to form your planets quickly, otherwise the star marches in and ends the show because it dispels all of that gas and dust that you need to make your planets from. So this particular discovery makes it a little more difficult for our theoreticians, unfortunately, because we've found, at only 2 million years, we've found very massive planets, and they're still accreting. So
you're seeing a planet forming.
That's right.
So there's about 2,000 or so exoplanets, in other words, planets outside of our solar system that we've discovered, and you've discovered the first one, actually, the newborn baby growing.
That's
right now.
Yeah.
So that's pretty exciting. Does that mean there's a lot more planets out there than we thought?
Well, the belief is there are a lot of planets out there. This is another new, very new, I guess, a new piece of knowledge that's only just been available in the last few years. And that is how many planets are out there. How, you know, if I look up at a star in the night sky, what's the likelihood that one has a planet? What's the likelihood that it has a planet that might be in the right zone to support life? All of these questions that people have been asking for centuries, suddenly we're starting to get numbers behind them. We're starting to get answers, and it's a very exciting time to be an astronomer for those reasons.
Professor Peter Tuthill and Dr Karl, thank you very much for talking to us.
Thank you, Dr.
Thank you.